Vacuum seal molding is a process designed to produce a sand mold using dry sand. This process is facilitated by vacuum pumping with a plastic membrane. The fully automatic vacuum molding line designed by our company for Suzhou Roka in 2007 has a productivity of 20 bathtub units per hour, with the annual production of bathtubs at 90,000 sets. The main equipment is a membrane unfolding platform and a lower box tectorial membrane device. The tectorial membrane device is driven by an electric motor and is moved overhead of the membrane unfolding platform by a hydraulic cylinder drive. The tectorial membrane device is lowered, removing the thin membrane from the membrane unfolding platform. Utilizing suction created by vacuum, it then lifts the membrane and moves to the heating unit. The tectorial membrane device is heated through electricity, and the membrane will soften. The lower box mold will begin vacuum pumping, with the vacuum suction causing the softened membrane to adhere to the surface of the mold tightly. The sand mold covered with the membrane will be transported to the painting station by automated conveyor, where workers paint the membrane surface evenly. The painted sand mold will then be transferred to the paint drying station on automated conveyors. The method of drying is by heat, generated from 60 kilowatt electrothermal tubes and circulated by an axial flow fan. The dried painted sand mold is then transferred by automated conveyor to the transferring station, where a specially designed hanger will be ready to cover the mold with the empty molding box, completing the box covering process. The process of the lower box membrane lifting consists of the lower box membrane lifting manipulator. There is a vacuum connection device on the manipulator. This device is used to complete the membrane unwrapping, box turning, and box closing. Upon completion of this continuous process, the molding box is transferred to the molding box layer board by automated conveyor. While the lower molding box is molding, simultaneously the upper molding box is molding, utilizing the same processes of covering membrane with the tectorial membrane device, manual painting, paint drying, and covering empty box. The process of the upper box sand adding, jolt ramming, and covering back membrane consists of a lifting vibrating table, switch of rain sand adding, and an automatic back membrane covering mechanism. The upper box molding and empty molding box is transferred to the upper box sand adding station by trolley. The lifting vibrating table is driven by an oil cylinder. The oil cylinder will stop as the table nears the rain sand adding entrance. 4 air springs will rise to move the molding box to the entrance of rain sand adding, holding the box firmly in place. The rain sand adding switch will be turned on and the sand adding begins. Using a finely calibrated vibrating motor on the vibrating table, the molding box and sand will be slightly vibrated with high frequency, making a high hard sand mold. When the molding box is full with sand, the sand adding switch is turned off. The vibrating table stops vibrating and declines. The automatic back membrane covering mechanism will strike off the sand in the molding box and cover the membrane on the molding box. Meanwhile, the molding box begins vacuum pumping, and the sand is sealed in the molding box, tightly adhering with the effect of negative pressure and thin membrane. The process of the upper box membrane unwrapping and molding box closing consists of the upper box membrane unwrapping and molding box closing manipulator. This manipulator will transfer the molding box to merge with the lower molding box by conveyor after removing the membrane of the molding box. Upon movement of the molding box, the sand mold will be transferred to the placing station by the molding box and placing station conveyors. Vacuum molding has numerous advantages. They consist of, number 1, castings having a high precision of size, a clear outline, and a polished and spotless surface. Number 2, a higher metal usage factor. Steel casting products will rise 20%, while iron casting products will rise 25%. Number 3, the necessary equipment is relatively simple, while the dollar investment is small. Number 4, in addition to cost savings on equipment, there is also cost savings for raw materials and labor. Companies using this process experience a sand recovery rate of greater than 95% compared to the wet sand process. Labor cost is also significantly lower using the vacuum method. In fact, it has been proven that companies using this method experience a 35 to 40% reduction in their labor cost. Number 5, molds and the sand molding box have a longer life in service. Number 6, the working environment can be improved. Number 7, it is easy to manage and organize production. The vacuum molding method has a relatively short production cycle with a process flow that is simplified and can be easily operated. Number 8, the applicable range for this process is extensive. Small, manually operated, low production, or the mechanical and automated large production amounts are both suitable for this process. It can be used for iron, steel, and other ferrous metals. It can also be used for copper, aluminum, magnesium, and other non-ferrous metals.